This is Lab 9.
Diffraction. I'm Sabrina.
I'm Kyler. Leah is our TA.
This is Opti 388.
But for this portion of the lab, we're taking a laser diode and imaging that laser diode across an aperture in order to produce diffraction patterns. So we image the diffraction patterns using a lens inside this tube that images that onto the detector. So the important thing that we need to consider here is the fact that we're using the Fresnel number to make sure that we're inside the Fraunhofer range, and that's like n is less than 0.1. And so we know that if we're on the image plane of the lens, then we're inside the Fraunhofer region because the Fresnel number dies over to 0.
This is our diffraction pattern for our 40 micron slit. This is our slit at 160 microns at the Fraunhofer region, which is when our Fresnel number is close to 0.1. And whenever we move it closer and increase our Fresnel number, our pattern condenses on itself until it focuses on the aperture. This is our diffraction pattern for our 40 micron and 250 micron apart double slit. And here we have our 40 microns by 500 micron slit, which, since we increased the spacing between them, more orders showed up. And here we have our 80 micron by 500 micron double slit. This one, since we have increased the size of our slit, it condenses our wave packets of orders.
So this is the diffraction pattern in the Fraunhofer region for our rectangular aperture, and we modeled this in MATLAB using the code provided to us in lab. This is the circular aperture as it moves from the Fresnel to the Fraunhofer region. So this is the SOM function modeled with the circular function, and as you can see, it should be symmetric, but it is not.
Here's our data for our rectangular aperture and circular aperture experiments, and from our sync graphs, we took our our maxima, our middle maxima, and then our second and our first and second maximas, and took the values there, and then we normalized it to fit our data. From these values, they're a little bit off, but we think this is from an error in our rotation of our actual diffraction pattern on our the picture that MATLAB used. And the further away from the center that our maximas were, the more inaccurate our numbers got. And then for our circular aperture, we did the same thing by taking the peaks from the first maxima and the second maxima, and then normalized it using our middle one. And these errors were a little further off, and we're not exactly sure exactly why our numbers are totally off, but we have a couple ideas. If it could either be scattered light, different sampling, and our SOM function wasn't totally centered.